Okay, well dear students, we have already covered second order systems, second order control systems in our lectures. In today's demonstration, we are actually going to see how closely the calculated values agree with the experimental values for a second order system. So, for this particular system over here, we have a series RLC circuit, and we have actually the transfer function of this circuit shown over here. And now for this particular system, if I want to calculate omega n, actually it comes out to be 877 radians per second, and the zeta for this system is quite low, it is 0.12. And if for these values of zeta and omega n I calculate the percentage overshoot, it comes out to be 68.4, whereas from this percentage overshoot, if I apply a step input of 5 volts, then C final will be, the settling value will be 5 volts, and then I can calculate the C max, which comes out to be 8.4 volts. Similarly, I can calculate the peak time and the settling time for this particular RLC second order system. Now let us see how closely these calculated values resemble with the experimental values. So I have set up this RLC circuit over here, and now if I go for the calculation of the peak value, can you please focus over here into the peak value? You see, I get the peak value of 8.4 volts, where I have the settling value C max to be 5 volts. So the final value of the output is 5 volts, and I get the peak value of 8.4 volts, which very closely resembles the calculated value which I have shown you on the whiteboard. Can you please focus over there? Yes, thank you. Now the second thing that we have calculated there is the peak time. The peak time by definition is the time from the start to the first oscillation, to the first peak of the oscillation. So I can now check it from the oscilloscope. I am just going to zoom in by changing the time scale, and then actually this is the first peak that I get. I can even further zoom into it so that I can just see the exact value, and you see over here, this is the peak that I get, and it is 3.8 milliseconds, and the calculated value is 3.6 milliseconds, which closely resembles the calculated value. Now if I want to see the settling time, then I can actually set it to here, and over here I have nearly all the oscillations decaying out, which is technically it is within 2% of the final value, and you can see we have the value 37.6 milliseconds on this oscilloscope, which closely resembles the settling time that we have calculated using the second order differential equation. So this is all for today. Thank you very much. See you in the next lecture.